Okay, sir. So let us try to understand the concept of Docker images, containers, and volumes. We know about image, we know about container. So we need to understand why do I need to have something called as volumes. Okay. So if you remember, uh, we have discussed that Docker images collection of layers. And I said that those layers are read only. Yes? Okay. Come on. Okay. Refer here for article on image layers. Okay, sir. So let us just try to, yeah, I've started the recording, sir. Let us just try to understand the concept. Okay. So I create container. Yes. And let us assume that this is our container. Okay. So container will get a disk. Why is this? Okay. Fine, sir. This is like a disk, but actually what is happening? This disk is basically created with the help of layers. Do you agree with me on this, sir? So whenever we create an image, this is, let me try to call it as layer A or layer B. Multiple layers form a image. This is something which you have learned. And one more thing which I have spoken about this layers are, these layers are read only. That means once we create this layers, there is no change that is happening. Okay. Right, sir. Now, if I basically get into the container, okay, that's a very, very important concept, sir. No audio now. Guys, am I audible over the web? Okay. Fine. So I'm inside Docker, and then let me try to pull this image, which is Docker pull Alpine, and then Docker image inspect Alpine. And now how many layers do we have? One layer. So depending on what image you are using, there can be n number of layers. We know how these layers are created and what creates these layers. But one thing which you need to understand is this layer is read only. That means that there are no changes that are happening on this. So when we basically create a container, what happens is, in addition to these two layers which are read only, there will be one layer. There will be one layer where you can write. Where you can write. So this write layer belongs to your container. This right layer belongs to your container. So whenever we are creating a container, what is happening? We have multiple read layers and one read write layer. Okay. So actually your disk, whenever I'm trying to speak about the disk over here, this disk is equivalent to union of all of these three layers. मतलब ये तीन लेयर्स का यूनियन ही आपका डिस्क होता है. ये मूड लेयर यूनियन है मी डिस्क. So for that reason, in the world of Docker, we have something called as storage drivers. The basic idea of storage driver is which is capable of combining this. Okay, right. Now, if I try to create one more container, so then what would happen? This container gets this disk, and this disk will get its own layer. Come on, fine. This disk gets its own layer. Okay, sir. Now, if you try to see, this disk is union of this, and this uses this layer as well as this layer. Am I clear on this? Okay, or let me do this. I think the better one would be okay. Now for this container, this disk is created by union of these three things, whereas this disk is created with the union of. So are the layers getting stored? So for example, if I've created 10 containers, okay, and I have not done anything in the read write layer, and this layer is 100 MB and this layer is 100 MB. So we are speaking about 200 MB. Same 200 MB is given to all the 10 layers. So you are not multiplying the storage, but virtual machines don't work like this. Are we clear on this point? Okay. ఒక इमेज నుండి మీరు 10 कंटेनर क्रिएट చేస్తే 10 टाइम्स मल्टीप्लाई చేయట్లా स्टोरेज. ओके, एक इमेज से अगर आप 10 कंटेनर्स बनाते हो तो आप स्टोरेज को मल्टीप्लाई नहीं कर रहे हो. Now, this is the design of Docker, but this design has a side effect. This design has a side effect, and this is a very important side effect which all of us have to understand. So, but till this point, am I clear? Yeah. If my image is of size 100 MB, right, in which we have two layers, and from that if I create 20 containers, then it is not multiplying storage. Physically it is accessing only the same layers. Okay, good. Now these layers are mounted on top of each other by using something which is called as storage drivers. So e mounting e combination ante evaru chestunaru? So that is achieved with the help of something which is called as storage drivers. Okay, now let me go and ask this question, which is something which we have been asking for a long time now. Docker info. And now if you try to look into storage driver, what is the storage driver which is present over here? Right now, earlier we used to have something called as augment union file system, many different file systems, but at this moment we have only one storage driver which is responsible for combining these layers and creating a virtual disk. Are we clear so far? Okay, right. Now then the immediate question is, okay, what will happen if this container generates some files or modifies existing files? Okay, so for that understanding, what will I do is, let us assume that I have a file in here which is called as 1.txt. ఈ layer లో ఏ ఫైల్ ఉందండి? 1.txt. and this container while running has added some content to 1.txt. okay, so there is one popular concept which is called as copy on write, which is called as copy on write. Why is audio not receiving? Again, to the people over the web, to the people over the web, am I audible? Okay, right. Fine, sir. So these two layers are combined, and this container is not changing 1.txt. This container is changing 1.txt. So now ideally I should not be doing any changes over here, because if I change this, it will be applicable to here also. Then what happens is this 1.txt get copies into this layer, and then here the modifications will be done. This strategy is called as copy on write. So whenever you are reading, there is no problem. But whenever you are making any changes, what happens? Copy on write happens. And where are all of those changes present? They are present in the read write layer. That's a responsibility of read write layers. So if you create a container, you are not adding a single change. Everything is running, application is running as it is. You are not generating anything. So your read write layer is empty. But if you are generating something, so for example, I'm running Nginx, it creates logs. All of those logs are stored in this writable layer. Okay. Now, till here also the story remains fine. See, but there is only one problem. This writable layer is alive as long as your container is running. Once you delete your container, that layer will be lost. This layer ఎప్పటి వరకు ఉంటుంది? Container ఉన్నంత కాలం. Once the container goes into terminated state, this layer also will be deleted. Okay. Is there any problem with this approach? First of all, do you understand how it works? Yeah. So for example, if this container deletes 1.txt, so first what happens? 1.txt will be copied over here, and then in this layer the deletion happens. No changes are basically going back to the bottom layers. This is basically the concept of Docker. Right. Now, for some time, let us assume that this container is MySQL container. What is that we do with databases generally? We insert data, we update data and all of that stuff. So whenever we are inserting data, where is the data getting stored? In read-only writable layer. And when you delete the container, what will happen with the layer? Data is lost. So whatever data that has been inserted into your database will be lost once you delete your container. Is that okay? This is the reason why we need something called as volumes. Okay. So what can volume do is, volume basically, for example, I am trying to work with MySQL or any database for that matter. For example, you are storing your data logically in some folder. Ante kada? Whenever any application writes the data, it stores in some folder. So let us assume that this is /app/test. Okay. This is where you have files. This is something which you need. And now what we'll try to do is, we will try to create a Docker volume. What is it? Docker volume. And then we will try to tell that whatever is happening in app/test, store it in a volume. Now you delete the container. This layer is deleted, but we still have the volume. Next time, whenever you are trying to run the container, you can use the same volume. So you will get the same data back. Right? With the concept of volume, we are actually not stopping removing layers. What we are stopping is, we are preserving whatever is the important data. So shall we try this first of all? But did you understand this concept first? What the concept is? We have layers. Layers are read-only. Since they are read-only, you can't modify them. Whenever a container gets created, then a writable layer will be created. Whatever changes which you are doing inside the container will be stored in that writable layer. The problem is, when you delete the container, writable layer also will be deleted. If there is some data which you think is important, then what we try to do is, we try to create a volume and mount it into some folder. And then even when your container is deleted, whatever you have written into this folder ends up in this volume, which you can reuse again while you are creating the next container. So that is exactly what these 3 articles are all about. Ee 3 articles meer chuste ade untundi. That is what I am trying to show you. So if you try to look into it, When will the layers be created? It basically speaks about that. And what is the impact of layers? Every container gets a writable layer, and then image layers are generally read-only in nature. So now what we can do is when we try to use an image and create two containers with the same image, most of the layers are all the layers are reused. Only writable layer is individual for a container. And when you delete the container, both the layers will be deleted. Okay. Now I've spoken about how does this combining layers work. For that, there are many storage drivers. In this day and age, you need not know about all of that because this is a default implementation. When Docker started, there were lots of storage drivers, but now it's always overlay 2. Overlay 2 is simple. It understands layers. Okay, because this is not a normal file system, right? So, మన hard disk ఇలా పనిచేయవు. So our hard disks don't work like this. So for that, they needed a extra driver. That is how they have implemented it. Now, if you try to look into volumes, what will volumes do? That is the example over here. Okay. So go through these three articles, these 3 pages. But let me try to do over here. Now what will I do is Docker run. Let me try to use -it because or we can do this also. Run -d -- name C1. Okay. And Alpine. And in Alpine, I'm trying to write sleep 1D. That means I'm overriding CMD. Yeah. And then let me try to create 2. So right now, how many containers am I running? 2 containers. So now let me get into Docker exec -it C1 /bin/sh. Okay. Now let me try to make their test. So let me get into test. In test, I'll try to create 2 files, 1.txt and 2.txt. Now I exit. Okay. I remove C1 container. There is no way on earth for me to recover that 1.txt and 2.txt because when I created new files, where are they getting created? In the writable layers. After that, what is it I've done? I've deleted the container. Now you create a new container with the same name, it doesn't matter because that is lost. Same thing happens with C2 also. Okay. So for that reason, what I'll do is I'll try to show you something called as bind mount. So in bind mount, what I'll try to do is I'll try to create a folder called as test. So I'll get into the test folder. And then I'll try to create 2 files, 1.txt and 2.txt. Where is it I'm trying to create these things now? On the system where Docker is installed. Now do you have test folder now? So let me try to create the same C1 and C2 containers, but this time I'll be trying to run. Okay. And then -v. Okay. And then I'll be trying to tell that mount test. So in my local folder, I have test, mount it to /test folder. అంటే నా లోకల్ సిస్టంలో ఉన్న టెస్ట్ ఫోల్డర్ని తీసుకెళ్ళి కొన్ని టెస్ట్ అందుకు /app అందాం. Yeah. So here what is it I'm trying to do? I'm trying to, just like how we do port forwarding, I'm doing folder mounting. Okay. Right. Now let me get into Docker exec -it C1 /bin/sh. Now let me try to tell echo hello. So that means this will print hello, but I want to write the text in a file which is /app/1.txt. Now, if you try to look into what are the contents in slash app slash one.txt, what are they? Right. Now, let me exit. Okay. Let me remove C1 container. Okay. Now, in the local folder, I already have test. And now let me try to see in my local folder in test, what are the contents of one.txt. Are you seeing hello? Now, next time I can create the same container. You can give the same name or a different name. Okay. Now, if I try to basically do this activity, Docker, okay, exec c1 cat slash app slash one.txt. Am I getting hello? So even if I deleted and recreated the container, since I am using the same mount, am I getting the same data back? Yes. So, but this is the ugly way of creating. Right? Why is it ugly way? Because in which folder your data is present is managed by me. Is managed by me. If I delete the folder manually, then it will not be under my control. It will be completely, there is a chance that the folders which you are creating can be managed by you. So we can achieve the same thing by looking into this command. Are you seeing Docker volume? Docker volume does nothing fancy. It will also create a folder, but that folder will be managed by Docker, not by you. Okay. Now what I'll try to create is Docker volume create my-wall. Am I clear, sir? Now Docker volume inspect my-wall. So it tries to tell that this is whatever you are trying to create will be created in this folder. ఇందాక మనం టెస్ట్ అని మనకు నచ్చిన చోట క్రియేట్ చేసుకున్నాం. ఇప్పుడు ఇది మై వాల్యూమ్ దానికి కావాల్సిన చోట క్రియేట్ చేసుకున్నాం. इससे पहले जब मैंने टेस्ट बनाया था मेरी पसंद की जगह में बनाया था, लेकिन अभी वॉल्यूम बनाया, लेकिन वॉल्यूम को डॉकर मेंटेन करेगा. राइट? ओके. नाउ what I'll do is docker container run -d -v. What is the volume's name? My-wall. This I'll be mounting it to slash data. In which container? In a container which is called as C2. And here, oh, hyphen name C2 Alpine. Sorry. Okay. Now let me use the same volume for C3, because you can use the same volume across multiple containers, or you can use the volume for one containers. But that is your choice. Now Docker exec C2, and then I am trying to tell that create a file which is called as slash data slash one.txt. Am I clear on this, sir? Now let me go into C3, and then let me try to look into what is present in data folder. Are you seeing one.txt? Okay. And when we did inspect, okay, Docker volume inspect my-volume. So let me try to get into ls and okay. Now let me try to remove Docker rm -f c1 and c2 and c3. I've removed all the three containers. But still, if you try to look into it, Docker volume ls, volume is still alive. Since volume is alive, your data is also alive. Next time, whenever you are creating the container, bind the volume to the same folder and you will get the same contents. Are we clear with this concept? Yes? Okay. So you take any database in the world, every database stores the data in one folder. Now what you need to do is you need to create a volume and mount the volume to that. Am I clear on this? Yes? Okay.
Hello.
So did you understood the concept so far? Yeah. Now here I'll try to speak about Docker file instruction volume. What is it? Docker file instruction volume. So let us assume that I am trying to create an application. I am trying to basically create a Docker file. Okay. So vi Docker file. And then in this Docker file, what I have done is I have written from Alpine and run. Let us assume that I try to tell that make dir / data. And I know that my application is basically going to write lot of data into the /data folder. Okay. User might or might not create a volume, but I want to ensure that whenever this container is created, a volume has to be generated. So in that case, what I'll do is I'll try to write a volume instruction and /. Am I clear on this, sir? So what is it I've done? I've created a volume. And then in the CMD, let me myself write sleep 1D. Any problem with this instruction? Yeah. So what is that I'm trying to write? I'm trying to write volume. Now over here, what this behavior is, whenever I'm trying to create a container with this image, if the user mounts the volume, it will use that volume. If the user doesn't give a volume, it will create a new volume. It will create a new volume. So Docker image build vol demo. Okay. So this is the, and let me use latest. It's okay. Docker image ls. So do I have vol demo, sir? Yeah. Now let me try to create Docker run -d -name t1. Okay. All right. Before I do this, I want to just run this command. Docker volume ls. How many volumes do I have? My vol. We did create this in the last step. Now, what I'll do is Docker run -d -name c1. Okay. Vol demo is the container's name, right? Antena? Yeah. All right, sir. Now let me execute Docker volume ls. So how many volumes are you seeing now? 2 volumes. Why did the second volume create? Because in the Docker file instruction, I have written a section called as volume. And I said that if the user doesn't explicitly mount a volume, you create one volume so that you're not losing data. You're not losing data. Now, let me try to create one more container, C2. Okay. So here what I'll like to tell is -v mount my -vol. I want to mount my -vol to /data. So this time I'm trying to create a C2 container, and here I have mount the volume. Now if you try to look into Docker volume ls. So the third volume is not created because you're using this volume. Am I clear on this, sir? Yeah. Right. So volume basically gets stored on the same machine where you have Docker installed. That's the first thing. And now while you are writing an image, if you think that there is some folder that has to be backed up every time, which is critical for your application, you write a volume instruction. When you write a volume instruction, what happens is if the user forgets to pass the volume, you're automatically creating a volume so that you don't lose the data. All the database containers have a volume instruction. All the database containers have a volume instruction. Okay. So that even if you delete your container, there is some place where they are storing this data. Right now in the world of Docker, you can use something called as Docker volume drivers and store it in AWS, Azure and all of that stuff. But we will not be doing any of that because our intention is to build the images, understand this concept, Actually, we'll be running all of our applications in Kubernetes. మన డాకర్తో రన్ చేయం అప్లికేషన్. డాకర్తో బిల్డ్ చేసిన అప్లికేషన్ తీసుకెళ్ళి కుబర్నెటిస్లో రన్ చేస్తాం. డాకర్ is like a packaging unit and actual execution happens on Kubernetes. That's the reason. Ideally in Docker also what you can do is you can install a AWS driver, and whenever you create a volume it will go and create a disk on Amazon cloud. But I am not doing all of that stuff because it is not required. Okay, we'll be doing all of that stuff in Kubernetes. Okay, can we check what is stored? I'm not sure, sir, whether you were part of this discussion or not, but when I said whenever you try to inspect, you will get this mount point. And I've shown this also already in the class, saying that whatever we are trying to write is basically present over here. Okay, all you need to do is inspect the volume, try to get the mount point, get into that folder, but don't directly change contents over there. That is how it is basically being managed. Are we clear on the concept now? Okay, sir. Now, let us assume that I want to run a MySQL container. So, Docker Hub, MySQL. Now, I'm not worried about what is written over here. I'm getting into this Docker image, and in this Docker image, are you seeing volume instruction? So what is the volume which they want to store? Okay, fine then. You take any database, sir, the story remains. Postgres kelte inkoka folder untundi. MongoDB kelte inkoka folder untundi. So every database or everything will have some kind of a volume. Now, whenever you are trying to create a MySQL container, even though you don't create a volume is getting created because they have written the volume instruction. But it is always a good idea to explicitly mount it. Even if you don't explicitly mount it, it's okay. But the problem is, if you don't explicitly mount it, the names will be cryptic in nature. Because you are not giving a name. This is anonymous volume that is getting created. It comes up with its own. Are we clear on this point, sir? Yes? Okay. So, now, let me go to MySQL container and let me try to run a MySQL container. Okay, just a moment. Okay. Let me open Perplexity because there are a couple of points which we'll be discussing immediately after this. Right. Fine, sir. Whatever it is, I'm least bothered about this. Okay. Over here, I'll be trying to use. Just ignore this part for now. I'll be speaking about it very shortly. Okay. Right. So I'm trying to run MySQL colon 9 dot. Before running this, if you remember, we had 2 volumes. Before running this, how many volumes did we have? There is no need for you to create a volume by size, sir. Okay. The reason for that is your Docker is basically trying to take the storage from your host, right? So ideally, whatever is your free space, you can basically allocate to it. But we don't basically put restrictions saying that it has to be this much only. For that cases, what we do is we basically go to the Kubernetes, and when we are creating these volumes, we try to tell that I want to create a AWS disk of size 5 GB only. Okay. There we put restrictions, not here. Okay. All of that space comes over there. Okay. Right. Now, I am not interested in this application, but let me try to do Docker volume. That is saying one unnamed volume got created. But what would have been a better way? Docker volume, create MySQL hyphen wall. And then when you are creating this container, MySQL 2, you should have done -v. Okay. MySQL hyphen wall will be mounted to /var/lib/MySQL. Now, oh, right. It is basically crying because of port mapping. Yeah, 3306 is already given, right? So let me make it -capital P. I'm not worried about which port it is. Okay, right, sir. Now if you try to see Docker volume ls, if you try to see, I have, okay, I should have given my wall. I've given MySQL hyphen wall. MySQL hyphen wall is correct, right? MySQL hyphen wall. Now let me try to create one more container. So MySQL 3 and MySQL 4. And if you try to look into Docker volume ls, if you try to see, I have two containers which are using the, so you can share the data across different containers also using this volume concept. Are we clear on this? So every database container will have what? Volume. So tomorrow when I ask you to run Postgres, so what is that you should be doing? Just go and search for Postgres. Okay. If you don't want to do all of this, ask Perplexity directly. Yeah. Get into Postgres. Are you seeing any of the tags? Just click on the tag. Search for something called as volume. So what is the volume? Yeah. So whenever you are trying to create a Postgres container, then what you need to do, you need to create a volume and mount that volume into this folder. Even if you don't do it, a volume is getting created, but that name is difficult to identify. That name is difficult to identify. That's it. Are you clear on this, sir? Yes. So whenever we are creating any databases, then or anything where storage is critical, we create a volume. If the image has a volume, that is a better thing. Yes or no? Docker file రాసేటప్పుడే volume రాస్తే అది better. ఒప్పుకుంటారు దీనికి? Yeah. Docker file लिखते वक्त ही अगर मैंने volume लिखा वो बेहतर होगा क्योंकि अगर user भूल भी गया तो भी आप volume बना रहे. Right? That is the basic idea over here. Clear on this? Yeah. So do we understand this Docker volume instruction now? Yeah. I am not sharing these examples because I want you to build those examples. So Docker file reference and volume. Okay, sir. Now data will be what? Fine, there is, why should I read it alone? Under the Calypso. Right. I'm not sure where is case 1. Data will be with C2 container only and not only shared with all the containers as we have created the volume. Okay, so I don't remember that C2 and C3, right? But let me try to do this. Let us assume that I have C1 container. Okay. And while creating the C1 container, I have not created the volume. So that means that every data is in the read-only layer. There are no volumes inside it. As long as C1 is alive, your data is present. But once you delete C1, whatever you have written, everything is lost. Then I have created a C2 container. And while creating the C2 container, what I have done is I have mounted something called as test folder into /app. And then whatever you have written in /app only, even if the container is deleted, is getting stored in test folder. Okay. Then the third case which I have spoken about is, this time I'll try to create a C3 container, but let me try to create something called as MyWall. I created Docker volume called as MyWall, and then this MyWall is something which I'm mounting to slash app. Now, whatever you have written in slash app folder is getting in. Now, even when you delete C, you create C4 now, and you have deleted C3. And while creating C4, again, you have used the same instruction. So you are getting all the data back. Okay. Then the fifth case, I've created a container 5, and in this, we had a Docker file. And this Docker file had a volume instruction, but you have not given any volumes. So what happens? An anonymous volume, that is the what do you call the SHA hash stuff will be created. So a volume is getting created with something which looks like this. But ideally, the better way would have been, okay, when I'm trying to create, ideally, this is what we do. I know that Docker file has a volume, but I'll try to create something called as my store. This is my volume. And then I'll be mounting my store to slash app folder. Okay. So even if you don't pass this, a volume is getting created. Now you have a named volume. In the earlier case, it was a unnamed volume. Okay. Banu, am I clear about all the cases now? One is without volumes, neither in container nor in Docker file. That means you are losing data. Second thing is you have mounted the volume. How do you create that volume? One is you can do folder mounting. Okay, whatever folder that is present on your system, you mount it inside the container. That is not so good idea until unless you have very specific use case. Third case, we create a volume and mount it inside the container. What is the best thing to be done while writing a Docker file itself? If there is some folder which is critical, expose it as a or create a volume so that if the user explicitly does it, or if he doesn't do it, you are still storing your data. This is the whole idea, right? Test/app will not be shared by why you cannot be shared across containers. I can create something called as C5 or C10 where I can try to tell that I want to test, and this time I can mount it into app folder. I can create C11 where I again mount the test into slash data. There is now no one stopping into number of containers. All of the cases over here can be repeated. Okay. So I can have one volume which I'm sharing across 100 containers. Okay. Right, sir. There are no restrictions, sir. But actually, when you basically mount in multiple volumes, when two containers are trying to write the same data on the same file at the same time, then you will get deadlock issues. Okay. So then you need to manage read and write permissions. Again, as I said, that is all something for Kubernetes. Right now, we are only focused on the concept. How do you implement it at an enterprise level is something which you worry at a Kubernetes level. Okay. Right, sir. Now, what I want you to do is, this is something which I want you to Google. Find out why I should use arg and env instructions in Dockerfile. Just Google it out. Anyway, I'll try to tell the answer, but I want you to do a research of a little bit. Okay, sir. So what was the reason why I should use arc? Arc can be used as a parameter while building images. Okay. So for example, while building the images, you need to pass some parameters which you are using in your run instructions. Okay. So let me quickly write one simple example with respect to that. Make there. Okay. So vi docker file. I try to write from Alpine. Okay. And then I try to write arc. Okay. Name equals to, I can give some default value, test. Okay. And in the run, I am basically trying to tell that echo hello to dollar name. Okay. Right. So that means that I'm creating a file called as test. Okay. Echo hello అంటే hello అని ప్రింట్ చేస్తుంది. ప్రింట్ చేసిన దాన్ని దేనికి రీడైరెక్ట్ చేయాలి? పోనీ ఇలా చేద్దాం. test.txt. So what is that I'm trying to do? I'm trying to create a file called as test.txt. And just for our understanding, if you want to run this application, I'll be directly trying to write, never use the sleep in your CMD. But since this is a experimental stuff, we are using it for learning, that's okay. Now what is it I'll try to do? Docker image build -t check :1 and dot. So what it has done? It has created a file called as test.txt. Now docker image build, if you try to do -, help. And now if you try to see, there will be something called as -, build arc. Now in your build arc, what you can do is you can give your argument name and whatever its value is. Now I am trying to do the same thing, but this time I'll try to call it as this. But I'll try to give -, build arc, and then I'll try to give name is equals to 1.txt. So what is it I'm trying to change? I'm trying to change the argument while building the image. So this time if you try to see, it as used 1.txt. While creating the image, if you want some parameterization, then you go for build arc. But one thing which you need to understand is arguments are not available when you run your container. They are available only while you are building the image. అంటే ఆర్గ్యుమెంట్ ఎప్పటి వరకు బతుకుంటుంది? ఇమేజ్ బిల్డ్ చేసేటప్పుడే దాని విలువ. ఇమేజ్ బిల్డ్ చేస్తే అసలు ఆర్గ్యుమెంట్ అంటే ఏంటి ఎవరికి కంటైనర్కి తెలియదు. आर्ग्यूमेंट का स्कोप रहता है जब आप इमेज को बिल्ड कर रहे हो. जो भी आप वैल्यूज पास कर रहे हो वो सभी इमेज बिल्डिंग के टाइम में ही यूज होते हैं. Okay, right. Now sometimes what we want is we want some values while we are running containers. That is the point where we use environmental variables. Okay, env can be used as a parameter while running containers. Okay, right. So if you want to set some dynamic value, so what could be a dynamic value? When I'm running an application, okay, my application uses a database, but where will I pass what is the IP address of a database as an environmental variable? Yeah, let us assume that you have an app service and you have a database service. App service needs to speak with database. How would I pass the connectivity details? I'll be using that as a environmental variable. Now what I'll do is, let me make a small change in this Docker file, and then let me try to create something called as env db_host. Okay, you can leave it like this, or you can give a default value. Default value is localhost. That means if you don't give a value, I'll be taking localhost. Now let me try to build the image, and this time let me try to call it as check 3. Now let me run the container docker run. Let me directly get inside the container, check :bin/sh, and then let me execute the command print env. Are you seeing print env where you try to see db_host is equals to localhost? Okay, so where did we got this value from? Environmental variable. In the Docker file, I've written the instruction called as environmental variable. Now let me exit it. Okay, I want to run the same thing, but while this time while running the container, I'm passing the environmental variable where I try to set db_host is equals to 192.168.0.10. Okay, right. So generally, it is a good idea to put this in quotes, because if there are some spaces, then we might mess it up. Okay, now print env. What is the value of db host? Does it make sense now? Yes. Okay, so generally whenever any runtime parameters, we'll be using env. Build time parameters we use arc. Okay, okay sir. Right sir. So these are the major Docker file instructions which we have been learning so far. In addition to that, there are some other Docker file instructions also. So for example, there is something called as stop signal. Okay, so if you try to look into stop signal, this is a termination signal. Okay, when should your container be stopped? If you don't pass anything, it is Control C. If you want to stop, just execute Control C. But if you want to override it, you can change the stop signal. Generally, whenever we are trying to build signals, this is not required. But if you want to override the behavior, you would use it, and you using this is almost a rare chance. Okay, and now there is a health check. Health check is you are trying to write a health check instruction which will try to tell to the Docker whether your application is running or not. This also I am not using it over here because I do all of these things in the Kubernetes. Okay, right, fine sir. And then finally, let me try to speak about .docker ignore file. Okay, right. Let me try to tell you a simple example of this. Again, cd dot make dir ignore. Let me get into the ignore file, and then let me tell that touch or make dir src and touch src / main dot. I'm creating some dummy files. Make dir docs. Okay, touch docs / main dot md markdown format. Okay, touch something like dot ve and touch kada make dir jata. Okay, touch dot venv slash one dot text. Okay, sir. So if you try to look into this, oh, touch. Okay, dot venv, right? Right. Fine. So I think I have 3 folders. Yeah. Okay. Now over here, I try to write a simple Docker file. I'll try to that from Alpine. Copy whatever is present into the current directory in slash. అంతే నేను ఇంతకు మించి ఏం చేయదలుచుకోవాలి. Okay, sir. Now let me try to build the image. So before building the image, let us remove all the images. Docker rm-f dollar docker ps -a hyphen. Now let me remove all the images. Docker rmi and docker images hyphen q. Okay. Docker volume prune. This will remove all the unused images, all the unused volumes. Sorry. Okay. Right, sir. Now, if you try to look into it, I have this, and to recollect, this was our Docker. Okay. Now, Docker image build hyphen t. Okay. So ignore colon 1. Ignore colon no అని పెడదాం. No అంటే అసలు ఇందులో మనం ఏమి ఇగ్నోర్ చేయలేదు. ఓకే. And then dot. What is this dot? Current folder. That current folder is technically called as build context. Is called as build context. Now here what is that you are trying to tell? Copy dot. That means copy whatever is present in the build context into the slash app folder. Okay, sir. Now let me try to get docker run -it ignore colon no /bin /sh ls /app. Okay. Or ls -al. Sorry, saying everything got copied. .venv got copied. Docker file got copied. Docs got copied and src got copied. Okay. Make sense? Okay. Fine. While I am building the Docker image, do I really need to copy the Docker file into that? Docker file copy cheyala nenu avasam ledhu kada. So I don't need to copy Docker file. So what I'll try to do is I'll try to create a docker ignore, and in this ignore I am trying to tell that I am trying to write what? Docker file. And now let me try to do the same thing. Okay. Ignore colon basic. Okay. Now let me try to basically ls -al /app. In this, are you seeing a Docker file now? Docker file కనబడుతుందా? కాకపోతే Docker ignore వచ్చేసింది. Okay, right. So what is Docker ignore file doing, sir? It is telling Docker that whenever you copy any files into the Docker, what are the extensions that should be ignored and what should be allowed. So now let me get into vi docker ignore and let me make it more explicit. I'll write all that dot docker ignore and venv and dot venv folder /* and dot venv. So anything inside venv and this, and then I am trying to tell that don't allow docs and don't allow anything inside the docs. Okay, this I'll basically call it as decent. Now let me get inside this and get over here ls slash app hyphen a. What is getting copied now? Untaniki em unnai local folder lo. If you try to look into my local folder, I have .ignore file, venv, docker file, docs and src. But inside the container, I wanted only src. So what is that I have done? In docker ignore file, I have ignored all the files which I don't want to copy inside my, right? So whenever you are working on Git, I'm quite sure you might have learned about .git ignore. Okay. In the same way, whenever you are copying the files, we should be writing .docker ignore, because we don't want unnecessary files ending up in our image. Are we clear on this? Okay. Right, sir. Does it make sense now? Yeah. Okay. Right then. So now let us basically get back, and what I want to do is, let's run a Postgres database inside a container. What did I want to run? A Postgres database. Okay. So how do you run Postgres? Go into Docker Hub and search for Postgres. And generally every database will have two important things. One is volume. Obviously we need to find out what is the volumes location. And the second thing is, for every database you will have credentials, right? What is the username? What is the password and all that stuff. Every database generally gives you environmental variables. So if you try to see, they are trying to tell that I have environmental variables. If you pass Postgres -password, that will be the password of Postgres. If you want to create a user, you can use this. So are you seeing this? These things, sir? Okay. So what we'll try to do is, let's create a Postgres database with password, user, database and volume mountain. Okay. I am not sharing the command, sir. I want you guys to give it a try. Okay. Now let me exit, or I'll do one thing. I'll delete this, add a new instance. Okay, good. Now let me choose which tag I want to run. Let me go with the latest. If I'm not wrong, latest was 17. Okay. So Docker pull Postgres :17. Okay. Now Docker volume create, and let me try to call it as libdb, libvol. I'm creating a volume. Any problem over here? Okay. Now I'll try to tell that Docker container run -- name of my database is libdb -e environmental variable. So what is the environmental variable which I need to pass? Postgres _ password. Postgres _ password is equal to, let me call it as password itself. Okay. Right. And then there is something called as Postgres _ user. So let me give this user as LT. Okay. What else? Okay. Postgres image sets up. Okay. Postgres _ user. Okay. If the user is not passed, it will automatically take Postgres as a default user. And then let me try to give a database also. -e, or let me try to write \. Backslash basically in the world of Linux means that my command is not completed. I am typing the rest of the command in the next line. Okay, let me try to call it as library is my databases. Okay, and then -v. What is my volume? lib-vol. And where I should mount it? So you will get the location somewhere over here. నా ఎక్కడో రాశాం కదా అది ఇక్కడే ఉంది రైట్ var lib. Okay, yes. And now what is the image which I am using? Postgres : right sir? అన్ని కరెక్ట్గా చేసి నేను ఒక్క ఏదో పని చేశాను ఇందులో. ఏంటది? డాకర్ RM మనం ఇచ్చింది ఏంటి? వాట్ వాజ్ ద నేమ్ ఆఫ్ అవర్ కంటైనర్? lib-db. Okay, all of my command was absolutely fine apart from one thing. I should have given -d. ఓకే, ఇప్పుడు మళ్ళీ ఆ పాత నేను ఏ పనైనా సింపుల్గానే చేద్దాం అనుకుంటాను, అది అవ్వదు అంతే. రైట్, ఫైన్ సార్, ఇట్స్ ఓకే. Right, so I've given. Now if you try to see Docker container, my Docker container is basically running. I have not exposed the ports. Okay, right. Now shall we get into this container? Yeah, so Docker exec -it. Okay, what is the name of our container? lib-db. Okay, now whenever you want to get inside the container, if you want to execute whatever you want, if you try to see, he is basically giving psql. This is the command. Okay, ikkada meer command chuste, let me try to copy this. This psql is the command line client. What is it? This psql is a command line client. So what I need to do is I need to basically give -d psql. There is no need for me to give host, but I want to give a user. And what was the user which I have set? LT. Okay. Oh, -u అంటే డేటాబేస్. ఒక పని చేద్దాం ఆగండి. psql command. I just need to figure out what are the arguments to it. Connect to the database. psql -d. And what was our database's name? Library. And I need to basically give -U. And what is the name of my user? LT. And anything else? Okay. Yeah. So am I inside the database now? Yeah. Right, sir. Now if you want, you can basically execute trying to tell that /l. So it is basically, so am I inside the database, sir? Yeah. Fine then. So this is basically your మనకు డేటాబేస్ రావాల్సిన పని ఏం లేదు ఇందులో. All we need to figure out is what are the environmental variables and what are the volumes which I need to pass. Right, sir? So let's run a MySQL database. So what is that I'll try to do? Go over here and then search for MySQL. So I'll select MySQL. For MySQL, obviously I need a volume. And then let me try to choose an image. Let me go with 9. So I'm not even writing the commands. Okay, so this is something which I'll give as an exercise. run MongoDB, MySQL, and Microsoft SQL Server with volumes in a container. Okay. You can directly Google for commands. All you need to do is understand those commands. What are the things which you are trying to basically pass? So over here, Docker will MySQL colon 9. While it is basically pulling it, let us try to look into where lib MySQL is its volume. Let us try to look at environmental variables. Are you seeing MySQL root password, MySQL user, MySQL? Okay. So Docker run hyphen name. Let me try to call it as MySQL hyphen. Oh, first let me create a volume. Docker volume create MySQL hyphen wall. Docker run hyphen d hyphen name. Let me try to call it as EMPDB, employee database or something like that. Okay. So hyphen e MySQL underscore root underscore password is equals to password hyphen e MySQL underscore database is equals to employee database. Okay. Hyphen e MySQL underscore user is equals to LT. So there is a root user and then there is a normal user. And MySQL underscore password is equals to LT password. Okay. And what was the volume which we have created earlier? MySQL hyphen volume. So hyphen V MySQL hyphen volume will be mounted to var lib MySQL. And the image which I want to run is MySQL colon 9. 9? Intena? Okay. So did I pass everything? Hyphen D. Yeah. If I can do one more thing also, hyphen capital P if I want to do port forwarding. Yeah. So Docker exec hyphen it. I want to run inside the database. So what is my database's name? EMPDB. But here I don't want to use shell. I want to use MySQL command line. MySQL hyphen user. What is my user's name? LT. Okay. And then ask for password is hyphen small p or capital P na gurtulede error vattadu dan prakaram chuddam. Yeah, small p. Right. And here I have to type LT. Endiki kavitham. Right. Am I inside this stuff? Now show databases. Okay. Now here what I'll do is let us do our quick experiment. MySQL create and insert into table. So we don't need to create a database because you already created the database, but I'll be trying to create some tables inside it. Okay. So what is our database's name, sir? Okay. So if you try to see show databases, we have EMP. So I'll be trying to tell that use EMP. So that means you are running inside the EMP table now. Either create chesa. Right. Insert one record and then select star from others. Ideally, your application will be inserting data. Here I'm manually running commands. Do I have one record? Now let me exit and then let me tell that Okay, so Docker RM, what is the database's name? EMPDB. Docker RM -f EMP. Did I delete the database, sir? Now let me try to recreate the database with exactly the same command. Okay, I'm using the same volume, same details, same command. If you want, you can change the name. It doesn't matter. Okay. Now let me execute inside the container. Okay. Use EMP. Select star from others. Vivek Ochinda? Yeah. Even if I deleted the data, I got my same database, same data back because I am preserving the data inside the. So this is how you run databases inside your containers. Are we clear on this, sir? So I wanted to try this experiment for 3 databases: Postgres, MongoDB, and MySQL. That is more than enough. Okay. So do we understand the concept of environmental variables now? Right? So did we understood multi-stage build yesterday? So what would be your ideal multi-stage? You write whatever you want on the top, but your end stage should be okay. Right, sir. One last thing. Okay. Docker Scout. I'm not sure whether they have done inside this or not, but let me see if I can. So what you can do is okay, we'll do this in the next session because I don't think so time will support. What I would recommend is whenever you try to run your application, they have not given us whatever image which we built, it is not necessary that it is secure. Okay, so we need some scanners to try to tell them whether they are secure or not. If you have time, if you think you can do this, try this. Okay, so are you seeing Trivi? Right? So I'm not sure whether I can install this over here. I don't have a. So try to install Trivi on your machine, Trivi image, and whatever image name which you have built. If you try to run that, you will get some scanned report. Don't worry about what that report is. Just run this command. Okay, if possible, install Trivi image, and whatever image name which you have built. If you do this, you will be getting some issues. Okay, and what we need to do is we need to figure out how to resolve them. Okay, what are the major resolutions? This one and networking. This is something which we'll be basically discussing in our next session, which will be on Tuesday. So we don't have a session for the next 3 days, right? So we'll be having a session on Tuesday. Tuesday will be the Docker's almost climax day. And from Wednesday onwards, our focus will be completely on Kubernetes. Okay, right. And when I'm basically going into the Kubernetes, the only takeaway for me is when I'm starting Kubernetes, images are ready. Okay, so that means your application images have been created from Docker, and then your application image has necessary details of what are the environmental variables which I should pass, what are the volumes which are existing. Okay, so ఇప్పుడు వరకు మనం మాట్లాడింది ఓన్లీ ప్యాకేజింగ్ మాత్రమే. ఈ ప్యాకేజ్ అనే ఇమేజ్ ని మనం కంటైనర్ రూపంలో డాకర్ రన్ కమాండ్స్ తో రన్ చేయం ప్రొడక్షన్. Okay, because we are not dealing with one machine, we will be dealing with many machines, right? So that is where we'll try to speak about Kubernetes. We'll start with a small cartoon story on Wednesday. Yeah, but till Tuesday, I would want you to learn as much Docker as possible. Okay, because majority of the concepts are done. The only thing that is left is networking, and I'll be speaking about a single machine networking because multi-machine is always on Kubernetes. Okay, right, sir. So happy Dashera to all of you, and we'll meet again on Tuesday. Right, thank you. Yes, Bharti, you should get it. Yeah. Right. Thank you.